Assalamualaikum student. We resume back our lecture to topic 6.6, Carnot cycle. So Carnot cycle is the most best known reversible cycle. So it is a reversible cycle composed of 4 reversible processes, 2 isothermal and 2 adiabatics. So one most common example for Carnot is heat engine. We also can the opposite of heat engine is refrigerator. So it's also reversible Carnot cycle. Refrigerator is also another example, but with different direction. So here I want to show the four main reversible process in Carnot cycle. So I prefer to show you the PV diagram. Okay. So for first process, you have a reversible adiabatic isothermal expansion. Okay, then you have a constant hot temperature. Start at process 2. Okay. So stage 1, stage 2, stage 3 and stage 4. Okay, so first one is reversible isothermal expansion. Okay. Second is reversible adiabatic expansion. Third is reversible adiabatic compression. Oh, sorry, I missed. So this is the process, and this is the last one. Okay, process 4 to 1. So in the first reversible isothermal expansion, so consider you have a closed system, gas contained in a adiabatic piston cylinder device. Okay, so start with you have a reservoir of energy sources at TH. Okay, so during process 1 to 2, your gas will expand slowly. Okay, T tend to decrease. Your TH tend to decrease because during expansion process. But take note that at the same time, some heat is transferred from the reservoir into the gas. So you have QH. Okay. So because of that, even though your TH is decreasing as the gas expand, but you apply some heat, so it's balanced out until the piston reach position 2. So here, because of your temperature already balanced out, your TH will remain constant from process 1 to process 2. Okay, so at process 2, you will have a reversible adiabatic expansion. So here at stage 2, your reservoir that was in contact with the cylinder head is removed and replaced by insulation. So that your system become adiabatic. So gas continue to expand slowly, and during expansion process, your TH will drop to TL. Okay, so here your temperature will drop from process 2 to 3. So your piston, we assume it is frictionless, and since it's slow expansion, so it is quasi-equilibrium, so this process is also reversible. So next is from process 3 to 4, we will undergo a reversible isothermal compression. So at stage 3, the insulation at cylinder head is removed. The cylinder is brought in contact with the energy sink at TL. So here, okay, your piston will be pushed inward, okay, by external force by do the work on the gas. So as the gas compress, your temperature will increase. Okay, temperature will increase, but take note that you will also reject QL. So even though your temperature increase, but at the same time you reject QL, so your temperature the heat will balance out, so your TL will remain constant. So it's the opposite of the first process. Okay, last one. Once we reach the reversible adiabatic compression, so now your low temperature reservoir is removed. Okay, the insulation is put back on the cylinder head, and gas is continue to slowly compress. So what happens is your TL will increase to temperature will increase to TH will increase to TL. So you have to understand all these 4 processes in Carnot cycle. Okay, basically I just explained this previously. So you start with process 1 to 2. So this line, okay. So okay, from 1 to 2 is reversible isothermal expansion. 2 to 3 is reversible adiabatic expansion. Then 3 to 4 is reversible isothermal compression. And here is last one, reversible adiabatic compression. Okay, you will have this part QH and here QL. Okay, go up. Okay, so this is just the explanation for previous slide. So let's continue. Okay, so as I mentioned before, so you have Carnot heat engine cycle that we discussed in previous slide, and we also have Carnot refrigerant cycle. The only there are two main difference here. So first, obviously you can see the direction is opposite. So here is 1 to 2. 1 here, 2, 3, 4. But this one is 1, 4, 3, 2. Okay, the direction is opposite. So first one is reversible isothermal expansion. Okay, your number 2 is here. Your number 2 become initially was number 4. So this process is reversible adiabatic compression. So you will go to compression process first, and then here is reversible isothermal compression. Okay, and after you finish compression, you will go to the expansion process. And because of that, in heat engine cycle, your work done by your work, okay, W net out, since you will require heat input and then reject heat here. So your work done by gas is during expansion. So in Carnot cycle is opposite. So your work input to the gas is during compression. Okay, I hope you can see the difference here. So this sign, okay, the direction are opposites. Okay, so we have two main principles for Carnot principle. The efficiency of an irreversible heat engine is always less than the efficiency of reversible one when operating between the same reservoir. So let's read down here. So N for irreversible is always less than efficiency of the reversible. And the second principle states that the efficiency of all reversible heat engine operating between the same two reservoirs are the same. So let me divide it. Okay, these two principles talk about the diagram on this side, okay, on the left side. Okay, ignore this on the right, the figure on the right side first. Okay, the second statement said that efficiency of the reversible heat engine operating between the two rivers are the same. Okay, so this efficiency of reservoir 2 is equal to and reservoir 3. So here, okay, and the first principle is this one. It's between 1 and 2. So your efficiency of reversible heat engine must be always greater than the efficiency of the irreversible. And the figure on this side is the violation, okay? Violation. Okay. So need to correct my spelling. Okay. No, okay. Violation of the principle, okay? So here you cannot actually, okay, the detailed explanation are in the textbook. Okay. As long as you can understand these two principles and the figure on the left side, then it's fine. Okay. So violation here is only show that your Q, okay, the reversible and irreversible heat engine operating between the same two reservoir. Okay. The reversible heat engine is then reversed to run as a refrigerator. Okay, when you have this, you can remember if it's reversible, you can become both a heat engine and refrigerator. But take note, okay, you need to have both reservoir. And you need to keep check with your Kelvin Planck and also close-year statement. Okay, that's all. The details are you can read the details in textbook. Page 294. Okay, that's all. Thank you.